Hello guys, let's continue the series of our teaching on organic chemistry. The last time we talked about alkanes and we mentioned and wrote some of the structures of the first 10 common alkanes we know at our level. Now today there are two important properties or chemical properties of alkanes that we cannot ignore. One of the chemical properties is combustion of alkanes. Remember, if you talk about methane undergo the same combustion reaction with ethane. The same thing is what? Propane. So whatever chemical properties methane is undergoing, the same chemical property is applicable to ethane, to propane, to butane, till the last, which is decane. That is the 10th carbon atom, the 10th alkane in the series. So they have similar chemical properties. Okay, these alkanes have similar chemical properties. So if I bring out the combustion of CH4 plus oxygen, it means that the same thing will happen to this and the same will happen to this. But I'm not interested about the combustion of alkanes. I am interested today the substitution reaction of alkanes, and I am picking methane as one of the homologous series, or one of the member of this alkanes group. One of the member of these alkanes, I am picking methane is the first compound in the group. So I'm picking methane. I'm going to demonstrate how methane react with halogens, and one of the halogens I'm going to pick today is chlorine. Chlorine is always common. Fluorine can react with them, iodine can react with them, and even iodine can react with them, yes, and bromine can react with them. But let us pick chlorine. How does chlorine react with methane or alkanes? Remember, we pick methane as a case study. So the first reaction you are going to see is you find out that the chlorine atoms or chlorine molecule will try to substitute the hydrogen atoms attached to the compound. Look at what we have here. We have methane, the structure of methane. Look at the structure of methane, which is the collapsed structure as this. Now, when this, methane reacts with chlorine molecule, what they do is they substitute the hydrogen atoms. This reaction is continuous because they will substitute hydrogen atoms until all the hydrogen atoms attached to this carbon atom is all substituted or are all substituted. When they are all substituted, that is the end of the substitution reaction. So we'll take it bit by bit. What happened? The first step of the reaction. Now, the first step of the reaction, number one, is where CH4 reacts with chlorine molecule to give us CH3Cl plus HCl is always given out. HCl is always liberated. So here, if you find that here, we have this compound known as chloromethane. This compound is known as chloromethane. So if I want to demonstrate the structure of this compound, it will become CHHHCl. So I want to name it. It's only one carbon. It means it is methane. The parent, hydrocarbon is methane. So it is one chloromethane, or some people call it monochloromethane. Some people call it monochloromethane, or you can call it chloromethane because it's only one carbon atom. So this is known as chloromethane or monochloromethane. That is the first one. So if you subject this chloromethane or monochloromethane to another reaction, which is the second stage, to another reaction with chlorine, look at what will happen here. We will have the same thing. Chloromethane reacting with chlorine, it will give us CH2Cl2 plus HCl will also be liberated. HCl will also be liberated. Now you find out that now 2 chlorine molecules or 2 atoms of chlorine has substituted 2 atoms of what? Of hydrogen here. Now hydrogen has 2 atoms here and chlorine has 2 atoms. So the structure goes this way. C, H, H, Cl, Cl. This is the structure. This is what the structure is talking about. Of course, the parent hydrocarbon is still methane. So this is, we have 1 1 1 1. So this will give us 1 1 dichloromethane. 1 1 dichloromethane. I'm not writing the IUPAC naming because I have not taught naming of these compounds, which in my next class I'm gonna do it. So here it becomes 1 1 dichloro what? Methane, because we have 2 chlorine atoms attached to this parent hydrocarbon known as what? Methane. So here becomes 1 1 dichloro because we have 2 chlorine atoms. So that's by the way. Now, if you subject 1 1 dichloromethane to the same reaction, CH2Cl2 plus chlorine molecule, you will see that chlorine will continue substitute hydrogen atoms attached to this parent hydrocarbon. So we are going to have CHCl3 plus HCl. HCl is always liberated. So now, look at the structure, Now, look at the structure of this. We have C, we have H, we have Cl is 3 now. Cl. The parent hydrocarbon is still 1. So this one is 1 1 1. 1 into 3, that is triple, which means this one is trichloromethane because we have 3 chlorine molecules attached to this parent carbon, which is methane. So this is trichloromethane. Okay? I'm not writing their name because I've not done the IUPAC naming of these compounds. My next class will dig into it. So the last but not the least is very, very important, where chloroform is formed. Now this one is subjected to the same reaction. So it's subjected to the same reaction, and we are going to have CCl4 plus HCl. This CCl4 is known as chloroform. So if I want to name this will become tetrachloromethane because we have 4 chlorine atoms. They have all substituted all hydrogen atoms attached to this parent hydrocarbon, which is methane. They have taken them away and substitute them. Okay, so this is formed. We call it tetrachloromethane. We are going to do naming of these compounds. And this compound is known or commonly known as chloroform. The compound is known as chloroform. So, if this methane can undergo those substitution reaction, that is alkanes, you know the group is alkanes, which means any other member in alkanes can undergo the same chemical properties, even combustion. This is a typical substitution reaction with halogens. And this reaction is often called halogenation, in a situation whereby alkanes react with halogens. This reaction could be iodine, it could be fluorine, it could be bromine. All you need to do is to just substitute the substituents, because this chlorine here is the substituent. Okay, they are the substituents in this. And see you in my next class where we will name these the isomers of these organic compounds. Bye bye. Jesus Christ.